SpaceX just leaked something massive through an FCC filing. Flight 12 launches January 23, 2026, carrying the first Starship V3 with all 33 Raptor 3 engines. Each engine now delivers 280 tons of thrust. That's 20% more power than Raptor 2. The entire industry is questioning how SpaceX achieved this leap. But here's what really shocked everyone. After Booster 18 exploded at Massey, most expected months of delays. Instead, Booster 19 hits the pad in December. How does a company move faster after a major failure? What did Raptor 3 unlock that makes this pace possible? Let's talk about what happened after everyone thought SpaceX was done for. When Booster 18 suffered that pressure incident at Massey, the internet exploded with predictions. This will push everything back 6 months. The tight 2025 schedule is toast. Industry analysts started writing obituaries for SpaceX's ambitious launch cadence, but here's where it gets interesting. SpaceX didn't panic. They had Booster 19 waiting in the wings, and within days they confirmed it's still tracking for December stacking. The question is, how many companies keep backup hardware ready to roll at this scale? The FCC filing tells us more than just a launch date. SpaceX requested authority to use communication frequencies from January 23 through June 28, 2026. That's a 6-month window, and people are wondering why such a long time frame. The answer reveals how SpaceX thinks about risk. If they filed for just 3 months and Booster 19 blew up during static fire in February, the FAA would launch an investigation. The launch would slip to May, and their authorization would expire. They'd have to reapply and wait all over again. So they built in buffer time, not because they expect delays, but because they're planning for every possible scenario. Does this sound like a company that's struggling or one that's mastered the art of contingency planning? Now, let's dig into what makes V3 different, because this isn't just an incremental upgrade. The booster gets 3 grid fins instead of 4, which might sound like a downgrade until you understand the engineering. These new fins are 50% larger and mounted inside the methane tank compartment. The top fin is gone because airflow analysis showed it wasn't contributing much during the glide-back phase. The result? Weight drops by 10 to 15%, and the booster gains better stability during that critical moment when it's falling back toward the launch tower. But here's the real test. Will 3 fins provide enough control authority when Mechazilla tries to catch this thing mid-air? The Raptor 3 engine is where things get serious. All 33 engines on Booster 19 will be the new generation, each producing 280 tons of thrust. That's 20% more power than Raptor 2, and it comes from a lighter, more efficient design with fewer thermal shields. SpaceX has been testing simultaneous ignition sequences and electronic thrust, vector control. But Flight 12 will be the first time all 33 fire together in flight configuration. The landing burn switches from 3 engines to 5, giving much finer control during touchdown. Think about what that means. SpaceX is betting their entire V3 architecture on an engine that's never flown before. What happens if even one Raptor 3 fails during that critical landing sequence? The booster itself grew taller by 1.5 meters. That extra height translates to 25% more fuel capacity, which directly impacts how much payload Starship can deliver to orbit. They also integrated a smooth, hot staging interstage, and this is crucial because hot staging puts enormous stress on the vehicle structure. The fuel transfer system got completely redesigned at Falcon 9 scale, with vacuum-jacketed insulation and improved feed lines that should save 10 to 15% of fuel by reducing losses. Every drop of propellant matters when you're trying to reach orbit with meaningful payload capacity. But can SpaceX prove these systems work together flawlessly on the first try? Ship 39 carries equally important responsibilities. It needs to reach low Earth orbit successfully, maintain stable flight long enough to test the new heat shield tiles, and demonstrate Raptor relight capability in space. The tail section shed most of its thermal protection because Raptor 3 runs cooler than previous generations. This is a bold move, reducing weight but also reducing safety margins. SpaceX successfully relit Raptor 2 engines on previous flights, but V3 is different. The ship now integrates docking ports and quick disconnects for orbital refueling, which is scheduled for full testing in summer 2026 with a dedicated tanker. Every piece has to work because lunar landing capability depends on mastering in-orbit propellant transfer. How confident is SpaceX that they can nail this on Flight 12? Here's where the timeline gets aggressive. SpaceX VP of Launch, Kiko Dorfmiller, said they're targeting January 2026. That gives them roughly 2 months from now to finish Booster 19, stack all the remaining sections, run cryogenic tests, install those massive grid fins, mount 33 Raptor 3 engines, and complete a full static fire. Most aerospace companies would call that schedule impossible. SpaceX calls it Tuesday. If everything holds, Booster 19 rolls to Pad 2 by late February or early March 2026. We'll witness the first liftoff from the new launch mount, the first flight of complete V3 architecture, and the first time Raptor 3 engines light up under real mission conditions. The pressure on SpaceX's team right now must be absolutely crushing. But Texas is only half the story. Colonel Brian Chapman, commander of Space Launch Delta 45, just revealed when Starship flies from Florida, early to mid-2026. That's January through June next year, and Chapman isn't speculating. His unit manages the Eastern Range, and KSC's LC-39A falls directly under his authority. The Starship pad there just got its OOLM installed onto the Flame Trench system in early November, meaning most heavy construction is finished. Once operational, SpaceX can launch up to 44 times per year from that single pad, 44 Starship flights from Florida alone. Let that number sink in for a moment. What does the competitive landscape look like when one company can launch more super-heavy vehicles than the rest of the industry combined? Blue Origin and ULA fought hard against this approval last year. Their argument was simple. SpaceX's launch cadence would force repeated evacuations of their own facilities for safety reasons. The blast radius from a LOX methane vehicle producing 17 million pounds of thrust is massive. Every Starship flight creates 3 moments of roaring Raptor engines: booster liftoff, booster landing, and ship return. Safety zones have to account for worst-case scenarios, and right now they treat LOX methane as equivalent to 100% TNT in blast calculations. But here's the irony. Blue Origin's New Glenn and ULA's Vulcan both use LOX methane systems. Limiting launches only for SpaceX would be fundamentally unfair. Chapman understood this, and his support allowed SpaceX to move forward. Should national security priorities override competitor concerns about launch frequency? Chapman made another fascinating point about future safety zones. As Starship proves itself reliable, blast damage assessment areas will gradually shrink. Falcon 9 already flies over 100 times per year with minimal disruption because the Space Force has extreme confidence in its safety record. Starship needs to reach that same trust level, and every successful flight builds that credibility. Eventually, SpaceX could approach 120 Starship launches annually from Florida without forcing competitors to evacuate every time. That's the future Chapman envisions. But getting there requires flawless execution on flights like Flight 12. Now here's where logistics get complicated. Florida doesn't have a star factory like Starbase, Texas. So where do all these starships come from? SpaceX is building a massive gigabay at Roberts Road, about 8 miles from LC-39A and 9 miles from SLC-37B. The structure is already rising, 75,700 square meters of floor space, 116 meters tall, with 24 giant assembly bays. Once operational in late 2026 or early 2027, this facility could theoretically produce one Super Heavy booster every 5 to 7 days and one Starship upper stage every 7 to 10 days. That's 50 to 70 complete vehicle pairs per year from one building. The scale is almost incomprehensible, but it also creates a problem. How do you move these massive vehicles from Roberts Road to the launch pads without shutting down half of Florida's road system? Until Gigabay reaches full capacity, every East Coast Starship will travel by sea from Texas. SpaceX ordered 2 heavy barges for delivery in late 2025 to early 2026. Boosters and ships will cross the Gulf of Mexico, loop around Florida's southern tip, and arrive at Port Canaveral. Giant cranes will lift them upright, SPMTs will roll them to LC-39A, and the integration tower will prepare them for flight. This entire ocean voyage becomes routine, just like Falcon 9 stage deliveries are today. Throughout 2026 and into 2027, every Florida launch begins with a long sea journey. But once Gigabay hits full production, everything changes. Florida-built starships will dominate the eastern range, and SpaceX's manufacturing capacity will finally match their launch ambitions. The pressure on SpaceX right now is absolutely enormous. They're managing B-18 aftermath at Massey, upgrading Pad 1, rushing Pad 2 to completion, and that's just Texas operations. In Florida, thousands of tasks remain, finishing the LC-39A Starship pad, completing 2 more at SLC-37B, and constructing 2 production gigabays. Every mistake gets amplified because they're the industry leader. Every delay gets scrutinized by competitors and critics. But SpaceX keeps pushing forward because standing still isn't an option when you're trying to build an interplanetary transport network. Can they maintain this pace without something breaking? So here's what we're really witnessing. Flight 12 isn't just another test. It's the moment SpaceX proves whether rapid reusability at scale is actually possible. Every aerospace company talks about reusable rockets, but no one has pushed the boundaries like this. 3 grid fins, 33 Raptor 3 engines, 25% more fuel capacity, all flying together for the first time on a vehicle that's supposed to land itself back on the launch tower. The stakes couldn't be higher. And while SpaceX races toward January 2026, their competitors are watching nervously. Blue Origin and ULA already tried to slow them down in Florida and failed. Colonel Chapman made it clear, if you can launch more, you should launch more. That's how progress happens. By 2027, when Gigabay Florida reaches full production and all 5 Starship pads go operational, we're looking at a completely transformed space industry. One company launching more super heavy vehicles in a year than the entire world combined over the past decade. But V3 has to work first. Those Raptor 3 engines need to fire flawlessly. The new grid fins need to provide enough control. The heat shield tiles need to survive re-entry. If SpaceX nails Flight 12, everything changes. If they don't, the timeline slips and competitors get breathing room. What do you think? Can SpaceX pull off V3 on the first attempt, or are they pushing too hard too fast? Drop your prediction in the comments. And if you want to stay ahead of every Starship development, hit that subscribe button and turn on notifications for new space review. We'll be tracking every step from now until that Raptor 3 ignition in January. Like this video if you're ready to see aerospace history get rewritten, and share it with anyone who still doubts what SpaceX can achieve.